Now, where was I? So the idea of energy balance, measuring energy in and out, these give us a nice accurate depiction of energy out. And I do that to frame the problem of obesity as being an energy imbalance. So my argument is that it's a persistent chronic energy imbalance that eventually leads to the development of a host of chronic diseases that are associated with being overweight and being obese. And the energy imbalance is what I'll try to describe when we talk about the physiology of obesity and diabetes. So there's at least two main theories that try to link an excess of energy storage with the inability to signal for insulin to signal properly and take up and dispose of glucose. So obesity and diabetes often come together. They're not only present together. There are situations where one can occur without the other. And of course, it makes sense to think, oh, obesity can certainly precede diabetes and be present without diabetes, but the opposite is true as well. People can be diabetic and not be obese. And I will say, as I think about it, that the diabetes that we talk about in this section will be type 2, so lifestyle-associated diabetes, non-insulin dependent diabetes, not type 1, which is a defect in the production of insulin by the pancreas. So these are a lifestyle disorder. Generally, the treatment follows similar parallels, but it's not the same between the two. Last, if I've presented an argument that makes sense, and if I frame diabetes and obesity as an energy imbalance, then restoring balance or creating the opposite imbalance might be a way to cure, over time, diabetes. And there's more than simply creating a negative imbalance or the opposite imbalance. There's a couple other really interesting new therapies that have shown considerable promise in curing diabetes. They're pretty extreme, and it might not necessarily be comfortable, but there's a nice section at the end, and we'll talk about cures for diabetes. And I don't mean pills. You often think of pill as like a medication to cure a condition, but this is one area where, like with most chronic diseases, pills will not be the solution. Pills can help control a lot of these, a lot of the comorbidities, which are not listed here. But as far as reversing and curing diabetes, a pill isn't what I'm referring to. It's a much more systemic intervention or therapy, but I'll leave that for the end. It's kind of a neat little afterthought. So let's take a look at obesity rates first and foremost. So this is an incremental approach. We're going to talk about prevalence of individuals that are overweight and obese, and also the prevalence of diabetes, and see if there are any parallels between the two, and then try to link them. So this is a little bit old. I think this is 2011 or 2012 data. 2009. Where is it?
At the bottom. It's a source ID.
Yeah. Okay, good. 2009 data. There isn't a lot of really up-to-date information. I did find some new information this morning, 2015 to 17, at Canada and the Nova Scotia levels, which is nice, and I'll show that coming up. But whenever you look, you're going to find something like this. The message hasn't really changed in recent years. It might have been worse in recent years, but we see this distribution where darker shaded areas are quote-unquote more obese, and you can see the obesity rates listed here. These are percent of the population, so all the way in black, a third of the population is considered obese in a lot of the southern states. In none of the provinces, which is nice. We don't have any of the 32 to 34% regions, I guess, in Canada. Everything kind of looks like we're a little bit better off. There's a bit of a higher density in the middle of the country and on the extremes. And this sort of parallels, in my mind, more rural areas. Seems that there might be a higher incidence in somewhat more rural areas. We're not doing very well in Nova Scotia and the Maritimes in general. Newfoundland and Labrador are certainly not doing very well with the highest rates of obesity in Canada. BC, on the other hand, has the lowest. And I've seen an interesting stat that this generally also parallels average age across the province as well. And most of these conditions that we'll talk about accrue with age. Obesity rates are higher as you get older. Diabetes rates are higher as you get older. And so if you have a higher average age of the population, you might also be more likely to exhibit higher obesity rates and diabetes. So those parallel more rural areas and higher average age. And we can see for context how we rate. We're not doing as badly as the US and Mexico, but scoring 4, or being 4th last in this list of countries by age-adjusted percent of obesity is not necessarily a good thing. So an industrialized country where obesity is on the rise, we don't want to be down in this bottom area here. We want to move up if at all possible.
Just curious, the national rate, is that also including the territories and we're just not seeing it? Or
No.
is there
No, the territories are grayed out because the population is so small that it might influence, there might be too large an error or not enough individual data. So they're not included in the average rate, and then they're not shaded accordingly. There is a little bit of information, for instance, on this slide, which is somewhat more recent, up till 2013. I think I pulled this up 2 years ago. These are the provinces with Canada at large ranked in decreasing order from the most recent data, 2013. Again, Newfoundland and Labrador ranks number 1, highest obesity rates, and so on and so forth. Nova Scotia is number 4. We have none of it ranked fairly highly. The Northwest Territories, in the middle of the pack, BC all the way at the bottom. And the numbers might vary slightly from here versus the last figure. More time has passed, so of course the numbers might be a little bit different. But this is a significant chunk of the population, right? 15 to 30%, a fifth or a quarter of the population in some cases, as being ranked obese, not overweight. This is just obesity, the incidence of obesity in these regions. It's a high proportion of the population. If we include overweight as well as obese in a graph like this, the rates jump to over 50%. And we can see those shown here in a nice graphical form. Not as up-to-date information as the last table. This is still 2011, I think, fairly recent. New Brunswick, 61%. Newfoundland, 62%. These are the combined overweight and obese percentage rates of individuals in the provinces. There's no national average here, I don't think. No. Similar parallels, though. More rural areas, central Canada, if you will, and then the Maritimes seem to have higher obesity and overweight prevalences. Less on the West Coast and in Ontario and Quebec. We have some information on the territories here. What little we were able to scrounge up. But even these numbers, depending on where you look, might be conservative. The data that I found this morning references a survey from also 2011-2012 that puts Nova Scotia at 70% for overweight and obese. And here we're scoring at 58. So depending on where the data comes from and what the report says, not a whole lot of consensus, but high. It's high. You have a question?
Yeah, so these percentages are adjusted, so that's why they're higher than the other. I was just confused, like why is now Newfoundland now 62%
Right.
compared to where it was like 30?
These include people that are considered overweight and obese, where on the last slide it was just the obesity rates. So some individuals are now included here that don't categorize as obese per se. They might be They have a higher BMI or a higher body fat percentage, but they're not classified as obese, so the last slide didn't include them. Question? Yeah.
Do you have data self-reported?
That's an excellent point. And what measurement is used to classify overweight and obese? The newest data that I have, I put a table together that shows obesity ranking by BMI and then self-reported physical activity. I don't know if this is self-reported as well, or if it's a high-quality measure. There's a lot of intrinsic problems with using BMI to categorize as overweight or as obese. It's just an easy measurement to make. I don't know the answer to that, but that would definitely influence the reporting results or the message that we're trying to get across. Yeah. Does it say here? No, I don't have it here. But what I want to show is at least whether these are self-reported and what the source of the data is, or the respondents to the surveys, if they're more healthy or less healthy population that responded to the survey. This same survey shows us also the incidence of diabetes. And so we can overlap, or I'll just switch back and forth briefly between this, which is overweight and obese, and then the prevalence of diabetes shown here. Not an immediate one-to-one matching. If we go back to overweight/obesity, diabetes, Ontario now leading the pack, coming out of nowhere. Not so concerning in central Canada, but the Maritime provinces still a relatively high percentage of diabetics in the population. So not an immediate overlap, which calls into question, can you directly relate the prevalence of obesity or being overweight to diabetes? Probably not. There's probably other factors at play as well. Socioeconomic status is a large one. The types of fruits and whole grains, actual physical activity comes into play as well, but it's a general oversimplification. Also draw from this figure the comparison of the incidence rates. Much smaller incidence rates for diabetes, so a tenth of the numbers for being overweight and obese. So there are a lot of people that would not be considered or that are not clinically categorized as diabetic that are perhaps overweight or obese. So again, not a one-to-one overlap. These numbers in general, fairly low. They seem really low. The most up-to-date information that I could find was a study done in 2012 that projected to 2020. We have the incidence rates still similar to what we saw on the last slide, about 5 to 6% in 2010. Here, I think this is 2011. And then the projected rates over 10% as we approach 2020. The massive increase from 2000 shown here with the thousands of individuals on the left. So this is 1 million, 2 million, 3 million. And the prevalence or the incidence rate on the right, 4, 6, 8, 10% of the population in Canada at large. So I don't really need to spend a whole lot of time hammering these points home. This is the siren song that you've heard for years. Obesity on the rise, childhood obesity on the rise, diabetes on the rise. And maybe it's even worth revising some of these points, because even though I point out here that, yeah, obesity and diabetes can begin in childhood, most occurrences are in adulthood, that might even be a dated statement. Now more than ever, I think the most recent stat was 2 out of 3 young children are considered at least overweight, and that seems to only be worsening. The majority seem to result in adulthood, and that parallels the idea that the incidence rates go up as you age. If you give a disease more time or a poor lifestyle more time to accumulate this chronic disease, it will. We don't really have a smoking gun for the cause of obesity and or diabetes. There's some genetic background, some hormonal dysregulation. Lifestyle is a massive factor. Although there are a number of factors that go into it, we can generalize and say the increased inclination of our society to be more sedentary reducing physical activity and increasing easy access to food probably contributes to this overall phenomenon. And I didn't put any numbers up for the costs of obesity. There's a whole other aspect other than the fact that you need to take insulin regularly to regulate blood glucose. There's emotional costs with obesity, there's body image costs, there's physical health care costs, there's out-of-pocket taxpayer costs associated with this, which is a completely preventable chronic disease. And maybe that is the point to really emphasize that more often than not, the large majority of cases should be completely preventable if we approach diet and lifestyle in a, I'll say, responsible or proactive way. Let's put it that way. And that's not a catch-all. There are some cases where lifestyle is not necessarily as effective, perhaps, but that most of these are preventable is a pretty important point to hit home, I think. So I don't have local diabetes rates, but I do have local obesity rates. When I went back to look for these tables, I couldn't find them for the life of me, so I can't give you the comparing or the contrasting information with diabetes, but like with most other conditions, we see that stepwise progression, where the national average here showing just obesity rates, not overweight and obesity, so we're back to the 20s to 25% numbers that we saw initially. Nova Scotia higher than Canada, Antigonish higher or on par with the province, but higher than Canada overall. You can see the combined numbers here as well. The general trend is intact no matter where you look. The more recent information that I did find is shown here, and it's a little bit more complicated than the last diagram. The top two rows are only differentiated based on whether it's overweight, BMI that scores overweight, or obese. Difference, of course, is overweight is what, 25 to 30 now? Is that still the going rate? Obese is categorized as a BMI over 30. And then there's morbid and super, which are like over 40 and 50. I can't keep track. They keep changing. But that's the difference. We see the number of individuals and the incidence rates here in Canada on the left, Nova Scotia on the right. No local information, unfortunately. And the same trend where the province seems to be higher than the national average. What I'd like to relate to is the diabetes rate, because we didn't have that on the last slide. Still generally higher in the province than the country at large. And Keegan's going to probably ask, why did it go down after 2015? We see this 2% drop. I don't really have the answer to that. It could just be that the number of respondents is lower. I thought about that before coming in. But on average, higher in the province than the national average, even though self-reported physical activity is on par with the rest of the country. Key here being self-report. Over half the individuals in Nova Scotia report getting at least 150 minutes of exercise or physical activity per week. This is of a moderate intensity, over 3 or 4 METs, 30 minutes per day according to Canada's physical health guidelines. But self-reported, take those numbers with a grain of salt. I'm trying to think of whether I would rank myself in this category or not. I don't know. Making lecturing is a fairly sedentary type of activity, so I don't even think that I'd be in this category. So we see this increased prevalence of obesity and diabetes, and the way that I frame it is as follows, like most chronic diseases, as a spectrum disorder. So we might have a scale here, which is just a general approximation of, call it weight or call it body composition or whatever surrogate you want, but there's a healthy versus an unhealthy version, and on the left hand we have normal weight or normal body composition individuals. On the right we have varying degrees of obesity, morbid obesity or super obesity or whatever the new term is, but we have new stratifications every 10 kilogram per meter squared apparently. These seem to parallel increases in chronic disease. This is the metabolic syndrome of conditions. So with increasing adiposity or increasing body weight, we also tend to observe a higher prevalence of diabetes, higher prevalence of heart disease, high blood pressure, stroke, dementia, depression, age. So it's not to say that necessarily these are all caused by having a high BMI or being overweight or obese, that they're associated with one another. They all tend to present together. And approaching this disease, it is important to know that I think people start somewhere and then move in one direction or the other. So some accumulation of positive, healthy lifestyle choices can move you down towards the healthy weight end of the spectrum. The opposite can move you towards the unhealthy weight end of the spectrum. You can start with some small degree of insulin resistance that becomes large and develops into full-blown type 2 diabetes as you move further along the spectrum at the right. You can improve insulin sensitivity so that you need less insulin to monitor or to regulate blood glucose, but it's never jumping from one end to the other. It's a spectrum where you can move up and down accordingly. And that spectrum is really the sum total, in my mind, of multiple daily, monthly, yearly energy balances. So if, and I'm not making the argument yet, but if obesity and diabetes are linked, they tend to present together. If they're linked so that one causes the other, then understanding the development of obesity is vitally important for understanding the development of diabetes and other chronic disease. And so like insulin resistance can develop gradually over time, being overweight or obese can develop gradually over time as well. It's never just one morning you wake up and you're recategorized. It's not the case. And so what would be the things that result in an increased body mass? Body stores energy to accomplish work later, and that's just an unfortunate reality of the genetics that we've lived on for the past hundreds of thousands of years. When we had famine, that was a regular occurrence. We'd want to store up energy so that we could use stored energy to accomplish work and survive during those periods of famine. Our body still does that, even though we're not in any danger of famine on the short term. And so the accrual of energy is simply, is there balance or imbalance between energy coming in on the left and energy going out on the right? And really, these are the only avenues for energy flow in and out of the body. You don't tend to excrete very much energy. There is some energetic value left over, but the body is marvelously adept at extracting energy from the food that you eat. So energy in happens to be what goes into your body. What do you eat? Energy out happens to be how much do you need to maintain normal processes, how recreationally active are you, and what structured, organized activity do you engage in as far as exercise is concerned. Energy in, energy out. Now the million-dollar question, the reason why there's so much grant money in this area is which is more important? Do you need both? Can you only diet and succeed? Can you only exercise and still eat cheeseburgers and succeed? Not that cheeseburgers are bad, in moderation. And what type of exercise do you need? Is strength training better than aerobic? Or is interval training better than endurance training? or is walking enough to tip the scales in favor of an energy deficit? Do you need fruits and vegetables as well to help with this balance? Is bad fat a factor that will make it harder to tip the scales in favor of energy output? So there's a lot of nuance and little individual details that we'll gloss over in this section, largely because we're also not in the nutrition department, so we can't spend a whole lot of time talking about whole grains and the different types of free fatty acids, although it is really fascinating. You know what? We will talk about it near the end. Sorry, I got ahead of myself. One of the theories that I use to try to link obesity and diabetes looks at the different types, or I'll call it species, of free fatty acid. There's saturated and poly and monounsaturated, and different kinds of saturated fats tend to be more or less reactive and gum up the metabolism works, if I can say so much. We'll talk about those a bit later on, or allude to them at least. So a lot of small, fine details, but overall the big picture is this balance. And so what we're gonna the perspective that we have moving forward is this balance. And when we go into lab, we're going to look specifically at measuring one side of the equation. We don't deal too much with energy in, but energy in is largely, it's not fixed, but it's not mysterious. There's no guesswork. Energy in is reported on any food that you eat. There's no surprise to the caloric content of carbohydrates and fat and protein. They have generally fixed caloric equivalents. The only thing that's not fixed is what you classify as fat. Depending on who you ask or where you look, fat has 7 to 9 kcals per gram. And that could be because fat as a macronutrient is made up of many different kinds of free fatty acids. Or if you remember way back to biochemistry, you remember triglycerides, you've got the 3 fatty acids on a glycerol backbone. If you include the glycerol in the energetic content of fat, it pushes it towards 9 kcals per gram. And the fats themselves make up the other 7. So depending on whether you think the glycerol is used or if it's just recycled and new fats latch on, somewhere in the range of 7 to 9 kcals per gram. Fat's longer or shorter too, and there's more or less energy accordingly, so that's why that's variable. But carbohydrate, 4 kcals, protein, 4 kcals, that's fixed. And so you have nutrition facts like this, and you can figure out, okay, well I have 12 grams of fat, that times 7 or that times 9 gives me X calories. 4 times 36 grams of carbohydrate, 4 times 17 grams of protein. I don't really know what this is. It seems to be a pretty calorically dense and nutrient-dense food. Lots of nutrients. It might be like one of those, you know, Greek yogurt, but they have like the full fat version. There's like the Greek yogurt, but then there's that like dessert yogurt with like the lemon or the caramel that you mix in. Might be something like that. There's just over 1,000 grams per container. Yeah, that makes sense. Anyways, we can calculate the energy in if you know how many servings you ingested and the content of those servings. Energy in is not hard to figure out. So we have the whole left side of the equation if you're meticulous with logging amounts of food and doing brief calculations, or if you keep up to date with MyFitnessPal or who knows what tool you're using. But the left side of the equation is laid out plainly here, and there are courses dedicated to understanding the left side of the equation a lot more than we are going to. But I feel like we should at least give a cursory nod to the nutritionists maybe among us, or at least on the other side of campus. To offset the intake side of the equation, we have our 3 building blocks: resting, physical activity, and exercise energy expenditure. And all of that can be approximated with indirect calorimetry. So indirect calorimetry is a measure of VO2, or the oxygen consumed. oxygen consumed goes to supporting energetic processes. And we are so sure of that, we can ballpark the cost as roughly 5 kcals per liter of oxygen consumed. So if you measure VO2 over a certain amount of time, and you figure out the total amount of oxygen that was consumed in that period of time, that times 5 gives us a rough estimate of the kcals expended during that same period. So we're used to seeing VO2, the rate of oxygen consumption per minute. Maybe at rest you're consuming, maybe you're stressed, maybe it's a liter per minute. And you measure over 4 minutes so that the math works out. In my example, 4 liters of oxygen were consumed during your measurement period. Well, if this holds up and it doesn't change very much, it has the tilde to mean approximately because there's a few decimal points worth of error on the left and right. But on average, each liter is 5 kcals. If 4 liters were consumed, 20 kcals were expended. If you measured all the oxygen consumption over the course of a day, that times 5 would be how much energy was expended that day. So logistically, it's difficult to figure out what the right-hand side of the equation is. It's hard to hook someone up to a metabolic cart for 24 hours. But we can get an estimate by measuring at different times and making a few assumptions. So let's just briefly recap. Why is it that oxygen reflects energy expended? The stylized cartoon of the electron transport chain would probably, I was going to say make Dan Kane roll over in his grave, but he's not dead, so he's not rolling over in his grave. Probably be enraged, up in arms by this brief, simple representation of the mitochondria. Mitochondria, of course, the powerhouse of the cell, like we all know. But what I'm showing you here is the link between oxygen and ATP, and oxygen is consumed at the end of the electron transport chain. Complex 4 reduces O2 to H2O, and that's why you breathe. That's why you breathe in oxygen. It goes here, right? It doesn't go anywhere else. So terminally, oxygen is reduced to water, and this process somehow is linked to energy way over here on this right-hand side. And I'll show you some fantastic slides that are actually from Dan's old PhD advisor. And I asked him at a conference. He presented these slides. I asked him if I could use them in class. They're fantastic animation showing the electron transport chain flowing. I'm not going to post them because they're actually, I think he copyrighted them. But he said for educational purposes, go ahead and use them. I'll show you that in more detail, but this is just a general graphic representation here first, showing you, or trying to explain, these two are linked. So we have the electron transport chain where all these plus sign protons move out. There's so much of a gradient they want to move back in. The only way they can move in is over here at ATP synthase. And they do that. In the process, we can harvest that energy and make ATP. So for every amount of O2 consumed, we consume it, reduce it to make water. We create a gradient that allows us to make ATP. We form ATP when that gradient is dissipated. So a few assumptions that we need to understand the linkage between these two sides are the formation of ATP doesn't just happen by itself. We don't always just make ATP in the mitochondria. I mean, we do. But we make it proportional to its usage. If we break down ATP quickly, we'll make it quickly in the mitochondria. If we break it down slowly, we won't make as much in the mitochondria. And we're always using ATP for things like the sodium-potassium pumps or the sodium-calcium exchangers. We're always harvesting energy to pump ions. So somewhere out here in the cell, we have a lower concentration of ATP, which pulls ATP out of the mitochondria. So there's ATP being used somewhere. It's supplied in here, and supply is always proportional to demand. That's one assumption that we have to make. Supply is always proportional to demand. We never run out. We never have a surplus. We do run out once, but only once, and that's when you die. You never run out otherwise, and there's never a surplus. ATP is always made in proportion to its usage somewhere out here in the cell. And that means if we can assume that production is the same as use, the next step that we need is to figure out, okay, well, are we only ever going to consume oxygen in enough or a large enough quantity to support the ATP being used? Basically, are we ever going to make enough of a gradient to satisfy the ATP demand? And the answer to that is generally yes. O2 consumption generally mimics or parallels ATP formation. So if we make more ATP here, we're consuming more oxygen here. If this is fast, that's fast. If it's slow, that's slow. These two are generally linked. So as ATP appears, oxygen is disappearing. That means linking these two things together, as soon as we consume oxygen, it's reflective of the cell or the body as a whole using energy. And these are not outlandish assumptions. If oxygen is consumed, ATP is used by the body. We don't ever add more oxygen than we need or lack oxygen when we need it. And so what we'll end up with, and maybe I'll just introduce the trace, and then we'll call it for the day. What we'll end up with is something like this. If we're measuring at the whole body level, VO2 over time, and the person is resting initially, they might do some exercise and then recover, and this is similar to what you'll do in lab. If we're okay with the assumptions on the last slide, and we can measure oxygen consumption, we can get a pretty good picture of the energy that was used during the period that we were recording. Often, we want to measure the energy consumed during exercise. And so, this is a nice short bout of exercise. It's pretty stable. It's at what we would call steady state, and you might take 3 indicative points, average them out, and say, okay, well, for our 9 minutes of exercise, we were at about 1.1 liters per minute. That's the rate that we were using oxygen. That means we can calculate a rate that we were consuming energy and figure out the cost of that exercise accordingly. Graphically, I like this as an introduction because we can simply figure out, okay, well, if this is the rate that we're using oxygen, the amount of oxygen is represented by this shaded area. And I know if I can figure out the amount multiplied by 5, I can figure out the energetic cost. So we're going to spend a lot of time discussing how to do these calculations, and there's some minutiae and fine details that we have to worry about. But if we have a ballpark idea of the area under the curve, we can calculate the energy expended. And so I'll leave it there for today. It's been a long one. We'll come back next week, so a week from today. Remember, we have a midterm on Thursday, so we're not touching this information for a whole week. But the area under the curve allows us to figure out the energy expended for that same period. We'll leave it there unless there are any questions. I thought I saw hands back here before. There might be stretches. No? Okay. We'll leave it there, and we'll continue discussing the energy expenditure side when we get back to class next week.